I'm going to talk about our paper, Prompt Mill, Boosting Multiple Instance Learning Schemes via Task-Specific Prompt Tuning. To begin with, the sort of whole sign image classification usually relies on multiple instance learning schemes. As shown in this figure, a whole sign image is divided into patches, and a feature extractor extracts features from them. These features are aggregated into a slide-level representation. Finally, a classifier predicts output label. However, existing multiple instance learning methods typically do not fine-tune their feature extractor together with the classification task, because this cannot fit in GPU memory. Thus, they end up using task-agnostic features, and that reduces performance. Another challenge is that it's not easy to train large models on pathology data, because there's not enough annotated data for such complex models. Instead, current works mainly use self-supervised learning to pre-train such models. However, such training is still task-agnostic. Our solution is to use prompt tuning. First, let's see what do we mean by prompt. Imagine that we have a tumor classification task. Without prompt, the frozen feature extractor will produce task-agnostic features. Prompt is like hint. It tells the feature extractor, give me more tumor-related features. The frozen feature extractor then produces task-specific features. Prompt tuning fine-tunes only a small fraction of the parameters, that is, only the prompt and downstream network. The large backbone is left frozen. It is a parameter-efficient approach and performs better when we have limited data. This makes it an ideal choice for whole sign image classification. In this paper, we propose Prompt Mill, a method that fine-tunes multiple instance learning using only prompts. With our prompt, we are able to inject task-specific knowledge into our learned representations. We do this with negligible additional parameters, and that's how we reduce overfitting. Like other multiple instance learning methods, Prompt Mill also consists of a frozen feature model and a classifier that performs multiple instance learning tasks. Our difference is added triangle prompt that injects task-specific knowledge. In the first step of training, we break up the whole sign image into patches. We then group these patches into multiple batches to save GPU memory. We fed each batch together with our triangle prompt to the frozen feature model. Please note that the triangle prompt is shared across all patches and all whole sign images. We then concatenate these features and feed them to the classifier, which predicts the label and calculates the loss. In contrast to standard multiple instance learning that use pre-computed features, in order to train the prompt, we need to actually compute the features during training. For larger slides, we will run out of GPU memory. To avoid this, we use an optimization technique called gradient retaining, and we describe it in detail in our paper. Our feature extractor is a standard VM transformer. Now let's see how it behaves when we give it a prompt. We divide the input image into patches and embed them into tokens. Then we concatenate these tokens with a class token and one more triangle prompt tokens to form our new input tokens. These new input tokens will be processed by frozen transformer encoders. In the end, we use a final class token to represent the input image. We evaluate our approach on 2 breast cancer datasets and 1 colorectal cancer dataset. Compared with standard multiple instance learning, which cannot be fine-tuned, our method achieves 1% to 3% better accuracy at a small cost of less than 0.3 additional parameters. Similarly, compared with standard full fine-tuning, we use only less than 1.3% of the original parameters, but achieve 1% to 8% better accuracy. Compared with full fine-tuning, we use 40% less GPU memory and 30% less time. We realize the side-level attention maps on the breast cancer on a colorectal cancer slide. If we zoom in, we can see that our network focuses more on the tumor-related regions. To conclude, we introduce a new framework, Prompt Mill, which introduces prompt to multiple instance learning for better whole sign image classification. Our method injects task-specific information and is thus more accurate. Our method is also parameter efficient, fast, and saves GPU memory. We'll explore other parameter efficient methods in the future. That's all. Thank you.